Hello and welcome to my Tech Fun. My name is Igor and it is time for another 3D printer review, and this time it is sent to me by Kywoo 3D company and the type is the Tycoon. And finally I have a 3D printer on review which doesn't use those V-slot wheels for linear motion, but it has the linear rods and rails on x-axis. And this box is sent to me by Kywoo for a review, and also they sent me the PEI sheet if I want to test it, so I will see how long will be this video. Maybe I will test it separately or at the end of this video. Few other specifications about this printer is that printing volume is 24 by 24 centimeters in XY direction and 23 centimeters in Z direction. It has a direct drive extruder. This means we can print TPU too. I will test that later. It has also installed auto bed leveling sensor, filament sensor, power loss resound function. It has 32-bit board and color touch display, and also it is prepared for Wi-Fi transfer. According to the website, the bed temperature can be set up to 110 degrees Celsius and the nozzle up to 260 degrees Celsius. This makes me think that probably it has the hot end where the bottom tube goes down, touching directly the nozzle, because usually this is then the limit of this 260 degrees Celsius, but we will back to this later. Okay, but now let's see what's in the box. Thank you card, user manual. I will try to follow this. On this side it is some the textured glass, on the other side is the smooth glass, and it has protection foil on it. Sample filament on the spool, nice. Accessories. The spool holder, legs, tools, SD card reader, pliers, spatula, clips to hold the printing surface. It is quite pre-assembled, so this is the vertical part of the printer. And this is the base of the printer. There is some grease on the linear rods. Power cable. And the box is empty. So basically this is the content of the package, and very interesting. Only 4 bolts are included in the package, and they will be used to mount this bridge to the base, and no more bolts, so the assembling will be very easy. But let's follow our user manual. Here we can see the part list. Quick check if everything is here, but yes, okay. Basically the assembling is described only on one page, so let's do that. Move to the left side. The back side is where the stepper motor is. I didn't mount the legs yet. I have to move the Z-axis higher. Probably this is the reason why you shouldn't mount the legs earlier, because they cannot fit into this hole. Pay attention that there is no wire between two alloy extrusions. And I will use the opportunity now to show you this timing belt here. So this has 2 stepper motors for Z-axis, and they have the 2-sided shafts. So on the bottom side of the shaft there is a pulley and a timing belt, and this is hold the 2 lead screws in synchronization when the stepper motors are powered off. They will not move once when we set the horizontal position of the X gantry. So very nice solution. Step 3, until it's in this position, is to connect the y-axis stepper motor, it's here, and the smaller connection is for the y-axis limit switch, and it's here on the other side. Step 5 is to connect the heating and thermistor wire for hotted bed. In step 6 we can install now the back legs. And step 7 will be the filament holder on the top of the printer. I have to unlock these two T-nuts, but don't remove it. And where they are parallel, they can fit into this slot. And now I can tie the bolt, and they will rotate 90 degrees and lock into place. And it is very helpful that we got these Allen keys with the ball head at the end, so we can use it under the small angle. Now it is time to mount the tempered glass on aluminum plate, but first I want to wash my hands because there is a lot of lubricant grease on the lead screw, on linear rails, on linear rods, so definitely you want your hands to be clean before you remove the protection foil from the glass. There is one more super important thing to check, and it is on the back side of the printer. So this is the power switch, the power cable, and there is a switch for the voltage. And I hope it's visible on camera too. So now it is on 230 volts, which is correct for my country, for Europe. If you are in US, then it has to be here 115 volts. And now I can connect the power cable, but I will not turn it on yet. And I can remove now the protection foil from the touchscreen. Since there are no springs or adjusting the bed leveling with those rotation knobs, but only with the BL touch, it is important that this X-gantry is parallel with the bed surface. I will use this piece of plate and move down the Z-axis. Almost perfect, so this should be preset in the factory by default, but if it's not, then I will try to set this, or maybe this one a little bit higher to show you. So on this side it sits now on this plate, and here I cannot place it below it. And now I will unloose this upper screw and try to lift higher a little bit this lead screw and then tighten it. It will be hard to do it in front of camera, not to cover what I'm doing, but now I can move this lead screw and I can place this plate below it. It sits on it now, and I can tighten it back. Quick check on the other side. Perfect. So now this X-gantry is parallel with the printing surface. The rest is work for the BL touch. And assembling is finished, but before I turn it on, I would like to take a closer look of this printer. Let's start with the y-axis. The whole printing surface sits on these two linear rods, and look how big distance is between these two rods. So this will give really good stability of the printing surface, and it is moved by this timing belt, and the stepper motor is on the back side. There is the stepper motor, and there is the limit switch. Now, one thing I don't really like, it's not too comfortable to set the tension of this timing belt. Well, in my case it is set correctly, because if I press it I shouldn't connect it too easily, or I have to apply very big force. But if it is not set correctly, in that case you have to unloose these two bolts and push back the stepper motor, and then tie those screws back again. It's not so comfortable like with those new printers where we have that bolt for the tensioner, but the good news is that you don't have to do it too often, maybe 1 or 2 times per year. And as you can see, there are no springs, so the position of the bed is fixed and the leveling is actually left to the BL touch. But previously we have to check that if the X gantry is parallel with the bed surface. Let's move to the X-axis. On the X-axis we have the linear rail and the timing belt is behind. Well, the tension is also correct, so I don't have to change it, but the tightening is same. There is the stepper motor and also we have 4 bolts. But it is not so easy to access to those bolts because they are inside this protection yellow plate. And if I want to remove this plate, it's not that easy. It's not complicated, but we have several bolts, but also the power supply is connected with these bolts here. So let's talk about the Z-axis. So we have 2 lead screws and 2 stepper motors. And I'm not sure if you are familiar that there is a existing problem with this solution with 2 stepper motors. When they are powered off, then the 2 lead screws may move from the synchronization. But it is solved here by this timing belt, which holds these 2 screws in synchronization even when the stepper motors are powered off. And also I can see that these are not just regular nuts on the lead screw, but also they are anti-backlash nuts on both sides, and there is a lot of grease, so I have to wash my hands after this again. About the electronic, well, it has 2 stepper motors on the Z-axis I mentioned earlier. This is direct drive extruder, so here we have the stepper motor behind the extruder, and it is metallic one. Extruder, and above it is the filament sensor, filament runout sensor, and we have the stepper motor on Y-axis. It's there. Now the power supply is, well, inside. It's hard to see. It is mounted outside with these 4 bolts, and the main board is here on the top. And this is a display. On the right side we have a slot for micro USB, TF card and SD card. And I noticed that these grips are really handful if I want to move it, so it's much easier using holding here. And there is a spool holder, and the filament goes directly down into extruder. Now let's turn it on. So far it is super quiet. I'm not even sure does it work. Yes, it's working. Wow, this is very interesting. And always as a first test I want to try to move the XYZ axis a little bit. Tools, move, only by 1 mm for the first test. Okay, Y, Z. This is loud. I have a feeling that it doesn't have those silent stepper motor drivers on Z-axis. Let's move by 10 mm. Yes, definitely. It's a pity. The moving is okay, and now let's try the homing for the first time. Oh. Now moves down, but with the beer touch it will touch the home position. I forget to mention that it has the beer touch for auto leveling sensor, so this means with the homing it will touch the printing surface. Only I have to set the Z offset, that's the distance between the beer touch when it's touching and the nozzle. After homing I move in the Z to the 0. And it looks like the Z offset is preset in factory correctly, but I will check that during the printing. Preheating. It's very nice and useful, this touch display, but I think the menu should be a little bit better. For example, I cannot see all the time what is the temperature on the bed and the nozzle, so I can see only if I go into the heating part. And I can see only now the bed, and only if I switch here I can see the nozzle. But otherwise I cannot see. Maybe during the printing it will be visible, but it will be good to see all the time somewhere the temperatures on screen. I set the temperature to 60 degrees Celsius, and this is the picture from my thermal camera. Okay, it shows 66 degrees Celsius, but I didn't set the emissions, so the real temperature may be a little bit different. What is important for me that the temperature is equal and it is spread equally on the print surface. It's preheated through the filament sensor and then into the extruder, and this knob is very helpful. Now let's see what's on provided SD card. For the first print I always recommend to print something from the SD card, because if there is some problem we know that's not the case by the slicer, because the G-code is prepared by the manufacturer. Before I start with the printing I will go Tools, Auto Leveling. So this process took about 2.5 minutes. So it took 3x3 mesh offset, and now it knows if there is some angle between the path of the nozzle and the printing surface, and it will compensate it during the 3D printing. But now I have to set the Z offset, and that's the distance between the beer touch and the nozzle. Printing auto leveling, confirm. So probably it will print some lines, and I have to go into the options and set the baby step, moving the Z up and down until I get the perfect line. And the printing is finished. I'm very confusing, so why it prints only on this part of the surface? And also look at this, on official video it suggests that this clip to be here on the side, and it will be here, it will hit the clip, the nozzle, or even worse, the beer touch may deform the pin. Even this I have to move back because it was here on line. So be careful, definitely I will suggest to Kywoo that correct these G-codes to be in the center of the printing and printing surface. If I want to use the whole printing surface, In that case, it has to be included to avoid nozzle hitting the clips. Of course, my solution will be I have the PEI sheet, which is magnetic, so I will place it on this. But if you are using this glass, then you have to use these clips which are provided in the package. Confirm, and we are done. Let's print something else. XYZG. Maybe this is the calibration cube. Interesting, this is G code from the SD card, and it's not even on the center of the bed. Until it's printing, let's take a closer look of the screen. We can see the printing time, the nozzle and the bed temperature, and this is the Z, and this is the fan speed. 255 means 100%. It is the scale from 0 to 255. And we can pause the print, we can stop the printing, or we have the option. I can set the temperature, fan, change the filament, change the speed. There are some more options, I will check that. Manual pause or turn off, maybe. Baby steps. So here I set the Z offset if I want to change it. And more, what's in here? Nothing else so far. As you can see here, we can set small offset on X, Y and Z. Of course, this is the most important, Z offset. I'm on the beginning of the printing, but I want to check this filament runout sensor. I will cut here the filament. Okay, here's... okay. Okay, let's try to take out this filament. At this moment I didn't know what to do. There is no need to cut the filament or something like that. Just go into the options and use the unload command. You will see in a few seconds. Unload filament. Confirm. Resume. So filament runout detection works correctly. And now power loss resume function test. Turn off the power. Resume. It's heating up the nozzle and the bed, and if we continue the printing, I hope. Okay, resume after power off, also working correctly. Okay, I will not torture anymore this cube. I will let it finished, and then I will prepare my own G code. And the printing is finished. Quick check the adhesion with the printing surface. Well, it's quite weak. I thought it can be stronger. There was some flowing at the beginning, and this is not the raft I thought at the beginning. Probably I have to play more with the Z offset. Quick check the dimensions. I'm not sure what is the size. 30mm, 30.08, 2997. It's 30.54, so I have to play with the offset definitely. This is the top surface, These are the size, so quite nice. It could be a little bit better. I can see some lines here, but one of the best cubes I printed so far. The only problem I have with this cube is the bottom layer, so I definitely have to fix that Z offset. I want to measure the power consumption, so it is 15 minutes now, and 16.92 kilowatt hours is on this clock, and only this printer is connected now. And after exactly 1 hour of printing, this is new value, 17.08. On Kywoo website I found this document how to prepare the Cura. Well, it's also the installation of the Cura, but these two pages are what I was searching for. So this information I have to enter into Cura. I already have installed the Ultimaker Cura software. It's the slicer, adding a non-network printer. And since the Kywoo is not in the list, I have to add the custom printer. Here I can give it the name, Kywoo Tycoon. And on this page I have to enter those numbers from that PDF document I downloaded a few minutes ago. This is the printing surface, enable the heated bed, and on extruder it is very important, 1.75 mm filament. And then slicer is prepared. I will insert the STL file, which will be the Benchy. And only a few things I will change here, 0.15 layer height, and also I will not change the temperature, only instead of the brim I will use a skirt. And because of the direct dry extruder, I reduce the retraction here to 2 mm. Bench. And it is interesting that it's a slicer, it was turned to the other side. But anyway, the cooling is from the back, from this position, so first I want to check how this one sticks much better. I lowered the Z offset. I wait for cool down the printing surface and then I will remove it. So it was printed in this position and the cooling was from this side here. And here it looks like that this overhang is not too nice. Maybe the cooling was a little bit weaker, I'm not sure. So until here this surface is not that nice. I hope it's visible on camera too. On the other side, well, it's a little bit better, and then we have this small shoulder. But the rest from here, the printing is perfect. Look at these bridges, almost perfect circle. The conclusions for the Benchy, yes, from here, from 10 mm and higher, that's the perfect Benchy. Maybe I even couldn't see better Benchy, but the problem is first 10 mm, and I'm not quite sure. Was it the part cooling or what's the problem on the lower part? Since Tycoon have a direct drive extruder, it's time to test some flexible filament. But first I have to unload this one. Tools, filament, unload. Heating up the nozzle and then it will unload it. Heating is complete and I can confirm and then unload the filament. And before I load it with the load function, I want to heat up the nozzle to 220 degrees Celsius, because the difference looks like the 200 degrees for PLA. I could use the load function, but I like this wheel because I can feel if there is any problem with the resistance. And I try to print this corner guard very fast. The printing speed will be close to the PEI printing speed, close to the 60 millimeters per second. This is speed for infill. I have to stop this first attempt. The direct drive extruder can handle this printing speed, but unfortunately it looks like there is some warping, if you can see. Definitely I should reduce the speed for the TPU flex filament, and I will do the second attempt. Stop, confirm. And at least I can check the adhesion. Well, it's not too strong. Okay, I will lower a little bit more the Z offset. I lower the Z offset a little bit more, and then I reduce the printing speed to 70%. The first layer looks much better now, so we will see it will be a success this time. The Z coordinate is on 10 mm, so I will speed it up now back to maybe 100%. So this is again the previous printing speed, like in first attempt, but now I already have 10 mm printed. It's on 20 mm now, and looks good so far. The Z-axis is now more on 31 mm, and soon it will be finished, and I can see no problem that I speed it up back to the original speed. The printing is finished, and immediately I want to check the adhesion. Wow, this was not too strong, but it was finished correctly. Very nice surface. Here I speed it up to original speed, and I can see that line where it was speed up. Here you can see the seams inside, so here it jumped the Z-axis, and look at this, even this designed net came out perfectly. No, just kidding, this is the stringing. This is typical stringing for the TPU because we cannot use big retraction, but it is very easy to remove. And even seams is very easy to remove with some cutting tool. Okay, I finished it now without camera, so yes, and this is the final result. So extremely nice surface in any direction, even inside. So yes, I can confirm. So Tycoon and the Artillery Sidewinder are two best printers I have. I have 10 different printers for TPU printing. Only I wasn't too happy here with the adhesion. All four corner guards are printed on different printers. And there is one more test. And that's the testing the PEI sheet which the Kywoo sent to me. So this is how it looks like. It still has that protection foil on it, and it will be placed on this aluminum plate. So the procedure is to remove this cover for the sticker. It is 3M sticker, and let me remove the PEI sheet. So this is the PEI sheet. It's on metallic plate, and this is the magnetic plate, and it has to be sticked to this aluminum plate here, and then this is removable. First I remove the Z-axis higher. It will be easier to work here. And I will clean out the surface with isopropyl alcohol. And now I have to mount this magnetic base. And pay attention, it is a rectangle, so it has to go in this position. I will start removing the sticker, maybe 1 inch, and I will start it from back side and continue with the sticking. And use some not sharp object to press all air below the sticker. I have these test specimens for impact test. Great, no bubbles below the sticker, perfect. It's strong. And definitely I don't have to worry that it will be moved. Now I can remove the protection foil. And as you can see, this is my solution, that I don't need anymore these clips. And now I can use the full printing area. And I will test it with the Benchy again, but this time I want to print it in this direction, because this front part will get the direct cooling. To see it will be better. And of course I want to test the new PEI sheet too. Back to PLA. Now, two things I want to do before I start with the printing new Benchy. And the first one is to clean the PEI sheet. And you have to do this every time with isopropyl alcohol before every print. And the second thing is I want to do again the bed leveling. So tools, auto level. And theoretically this is not necessary, but just in case, if for example the thickness of PEI sheet is not equal, or maybe the glass was under small angle because there was some dirt between glass and aluminium, I want to do this auto leveling again, once only, and it will create a new offset mesh, and use it with my next printings. That's the good with the BL Touch, that the Z offset I don't have to change. Even if I have different sheets, I can replace them, but the BL Touch always take the measurement from the top surface. And the printing is finished. Immediately I want to check the adhesion. Oh, it sticks good. This is why I like the PEI sheet. So this is the first Benchy and this is the second one. Let's see the advantage of the flexible plate. And here they are side by side, so this is printed in first attempt and this is printed now. And it's much better, not because of the PEI sheet, but because of the position. Because now this one gets the cooling from the front. And properly here you can see the biggest difference, because this was the back side in the first attempt. Even if this was printed with a 0.2 mm layer height, it is way better. But of course only on first 10 mm. For some reason here where we don't have the bigger overhang, it's perfect in both cases. But don't forget, in Cura you have to place it to be in front of you, the cooling part, because during the printing it will be rotated in 180 degrees. Okay, and now the conclusions. And now the conclusions. I will repeat myself, but from mechanical aspect this is almost perfect 3D printer. I mean this type with the moving bed. It has this double frame super rigid structure. On x-axis it has the linear rails. On y-axis it has a linear rods, but on bigger distance, so it gives better stability to the printing surface. On z-axis it has two lead screws with two stepper motors. but also they are connected with timing belt. So even if the stepper motors are powered off, they will stay synchronized. And once we do check the linear rail to be parallel with bed surface, and we adjust the Z offset, we are done with bed leveling. There are no springs, there are no knobs, so everything will be done automatically. It has the BL Touch auto leveling sensor. So from mechanical aspect, really almost perfect printer. Only one thing I'm missing from mechanical part, and that's the tension screw. We can see that even on those budget printers, it will be much easier to set the tension on the timing belts. But good news is that once it is preset, and we don't have to touch it maybe a year. But even then it is not too complicated, but it would be more comfortable. It just rotate that screw and set the tension on the belt. Now from electrical and software side, I can see a space for improvement. First of all, I don't understand why they didn't use silent stepper motor drivers on the Z-axis and on extruder. But during the printing it is not that noticeable because these two extruders works less. So X and Y axes are more important, they're moving more during the printing. But it would be nice if we would have all 4 stepper motor drivers silent. Yes, 4, not 5, because only one driver we have for 2 lead screws. And this means we cannot use that command to auto-adjust the X-axis. If there would be 2 stepper motor drivers separately, then we would have even that possibility that we don't have to adjust this X linear rail manually. It could do automatically. Another thing, two information always has to be visible on display, and that's the temperature of the nozzle and the printing surface. Why? Well, first, for safety reason, can I touch it or no? And also, you should never turn off the printer until the nozzle is not cooled down below 50 degrees Celsius, because that fan on cold part always has to work to prevent that heat to go up. Otherwise you will have unpleasant surprise next time you want to print something. This power switch could be maybe on the side or front, so it's a little bit hard to reach if for, I don't know, emergency stop you want to turn it off. Somehow they should improve those G-codes on SD card, because they are not centered. For this cube it doesn't matter, but also that leveling G-code for that rectangle, it's not in the center neither, it's on the edge, and I hit the clips you saw in the video, and if I want to use the whole printing surface, I can't, because those clips are here and they're in the way. So pay attention to this if you want to print something big which will use the whole surface, because theoretically it is 24 centimeters and 24.5 is this length. So we don't have a space for clip. In my case, I solved this problem with the PEI sheet, magnetic sheet. I don't need those clips anymore. And definitely I will recommend you, if you buy this printer, buy it with PEI sheet. Not because that you don't need the clips. PEI sheet is much better, much reliable. Always clean it with isopropyl alcohol before every print. And you will not have any problems during the printing. Pay attention with PETG. PETG may stick too good to the PEI sheet. In that case, maybe you should use some separate agent like glue stick or hairspray. And that will be it. So really nice printer. Definitely I recommend as a first printer, because you just put it together very quickly and it is ready for printing. And you don't have to mess with the bed leveling, and it is ready for use. Maybe a better hot end would be better, to all metal hot end or something like that, to have higher temperature, not only 260 degrees Celsius, but if you want to print maybe just PLA, PETG, ABS, TPU, it's enough. This was really interesting printer. I really enjoyed in the review. Thank you for watching and happy printing.